Hello, in this video I'm going to continue working on the code refactoring that I created in the previous videos, and in this part I'm going to work on named arguments. Okay. So to remind you, the refactoring we built allows us to change the type of parameters from action or func into custom delegates, right? So basically in this test we have an action of string parameter, and when we refactor it, the code refactoring creates a new delegate and uses that delegate instead. If we use multi-line comments like this one here to name the parameters of the action or func, the code refactoring would use such names when it creates the delegate, right? Okay. So the code refactoring also handles callers. For example, this method here has two callers, this one here and this one here, right? And if we refactor this parameter, the code refactoring would detect that this caller here passes its own parameter as a value, right? And this caller here passes its own parameter as a value, right? And therefore it changes the types of these parameters into the newly created delegate, right? Okay. Now in this video, I'm going to continue working on this code refactoring, and I'm going to support named arguments. So I'm going to create a test first. So in this test, I'm going to use named arguments from the calling side, but I will specify the arguments in the same order of the parameters. Let me show you. Okay, so here in this test, I added another parameter called param1 of type int, and I'm using it here. And then when I'm calling method 1 here, I'm passing 3 as a value of this parameter, and of course I'm passing this parameter here as a value of this parameter, right? Okay, and here I'm using named arguments. So here I'm using right to indicate that I want to specify the right parameter, right? And I'm using param1 here to say that I'm going to specify the value for the param1 parameter, right? And here I'm passing arguments in the same order of the parameters, right? So I'm specifying a value for the right parameter first, and then the param1 parameter, which is the same order here, right? Okay. Let me modify the expected code now. Okay, and let me run the test. And the test passes. Great. So now I'm going to create a similar test, but I'm going to pass arguments in the reverse order of parameters. Let me show you. Okay. So here when I'm calling this method, I'm passing a value for param1 first, and then a value for the right parameter, right? So the order of arguments here is not the same as the order of parameters here, right? And in C#, we are allowed to do this by using named arguments, right? Okay. So let me run the test now. Okay, and the test fails. So let's see why. Okay. So here it seems the caller code is not what expected, right? So let's see what is the actual value. Okay. So the parameter of the caller method didn't have its type changed, right? And let me show you why this happens. So this find source parameters method, we use it to find the parameters of caller methods that are used as arguments for our parameter, right? And here when we find the invocations of our method, we are using the index of the parameter itself as a way to know which argument at the caller side is used as a value for this parameter, right? And without named arguments, this is correct, right? Because without named arguments, we must specify values for parameters in the same order as parameters. Okay. So in order to fix this, we need to be able to tell for each argument what is the corresponding parameter, right? And Roslyn does provide an API for this. Let me show you. Okay, so here in this line, I'm using the semantic model to get what is called an operation that corresponds to the invocation expression, right? And this returns an object that implements I operation. And here in this line, I'm expecting this operation to be an invocation operation, right? Because here we have an invocation expression. And you can think of this API as a way to get semantic details about operations. For example, this I invocation operation, it represents the semantics of an invocation, right? So here if I use this variable, let me show you what I can access. So here I can access the target method that is being invoked, right? And here I have arguments, which is an array of I argument operation, right? So basically, if I access the first argument, I get this I argument operation for the first argument, and using that I can access this parameter property, and this will be the parameter that this argument is being passed as a value to, right? Also using this syntax property, I can get the syntax node that corresponds to the argument, right? Okay. So here, instead of depending on the parameter index, I'm going to use the arguments in this invocation operation to know which argument corresponds to our parameter, right? Okay. Okay. So here I'm getting the argument operations and then selecting the one of which corresponding parameter has the same index as our parameter, right? And then I'm getting the syntax node for that and casting it to argument syntax. Okay. So let's run the test. Okay. And the test fails. Okay, so let's see the actual value. And here, the type of the parameter in the caller method was not changed. So let me show you why. Let me add a breakpoint here and debug the test. Okay, so here we expected the operation to be of type invocation operation, but the real type of the operation is an invalid operation. And let me show you why. So here when we refactor this parameter, we create a delegate, right? And we use it here. So after we create the delegate and use it as a type for this parameter, we look for callers, right? And here when we find this invocation and try to get a corresponding operation, it gives us back an invalid operation because of this error here. And basically in C#, we cannot convert a delegate into another delegate implicitly, even if they have the same signature, right? So here, to make this code compile, we need to create an instance of the right delegate. Okay, now this code compiles. But this is not something we want to do, right? So this means that once I change the type here, it will be hard for me to get an invocation operation here, right? So I'm going to use a different plan. Let me explain to you. So let me undo the changes first. Okay. So my plan now is to find all callers and figure out all the changes that need to be made, both to the method itself and to the callers, and only then do any changes to the method or the callers, right? So basically I'm going to calculate all changes and only then apply them. And this will solve our issue, because here when we try to get an invocation operation, we will get a valid one, right? Okay, let's continue now. Okay. So first, I'm going to create a class to represent a change to a single node. Let me show you. Okay, so this change class represents a change to a single node. It has a node property, which is the original node that we want to change, and then it has an instance of a delegate called update syntax node. And this is a custom delegate, and this delegate represents the change that we want to make. It takes the node itself, which is the node here, but potentially in an updated document, right? And this delegate returns an updated node, right? And the reason we are not simply using a syntax node here to represent the new node is because we want this change class here to know how to calculate the updated node given a potentially changed node, right? Because if we have multiple changes in a single document, once we process the first change, we will get an updated tree, right? And therefore each change should know how to calculate the updated node based on a potentially updated node, right? Okay, so now I'm going to create a class to model changes to a single document. Okay. Okay. So this class contains a document ID property and a changes property, right? And the document ID represents the document that these changes belong to, right? And this add method, it allows us to add a change to the changes, right? But because this class is immutable, we always create a new instance, right? Okay. So next, what I'm going to do, I'm going to create a method that takes an array of changes for document, representing changes to multiple documents, and a solution to apply these changes to, and the method would return an updated solution. Let me show you. Okay. Okay. So this apply changes method, we give it the solution that we want to apply the changes to, and then here we give it the list of changes, right? And it's worth noting that the nodes here, inside the changes here, must belong to the solution, right? To this version of the solution, right? Now what I'm doing here, I'm simply looping through all the documents. I'm getting the document here. I'm getting the root node for that document. I'm getting the list of changes for that document. And then I'm calling the replace nodes method, right? For each change, I'm passing its node here, right? And then in the body of the lambda here, I'm first finding the change that corresponds to the node passed to me by the lambda, and then I'm using the update syntax node delegate to calculate the change represented by this object here, right? And because this lambda parameter represents the original node, the node from this collection, I'm using it here to find the corresponding change, right? Okay. So once I apply all the changes for a single document and calculate a new updated root node, I'm updating the solution to use this updated root node, right? And I talked a lot about this replace nodes method. See the previous 2 videos to make sure you understand how it works. Okay, so now since we have this method ready, our job now is to calculate the changes for each document, right? And once we have that, we can simply call this method to calculate an updated solution, right? Okay. Okay, so this is the method that is supposed to create an updated solution, right? So here I'm going to create a dictionary to represent all the changes that I want to be made to the solution. Okay. And now I'm going to create a local function to help me add changes to this dictionary. So now I can use this add change function to add a change to any document, right? And this will simply update this dictionary to add the change. And here in the body of this function, if this is not the first change for this document, I'm adding this change to the existing list of changes for this document, right? If this is the first change for this document, I'm creating a new list of changes that contains this change, right? Okay. So here I'm creating the new delegate declaration, right? And now I want to add a new change to the document that adds this delegate as a member of the class, right? Currently we are doing this here, right? We are updating the root node to update the class to contain the delegate as a new member. Okay. Okay. So I have moved these variables here so that I can use them here. And here I'm creating a new change, and the node I want to change is the containing type, which is the class that contains the method, right? And here when I'm given a potentially changed containing type, I'm updating its members to contain the delegate, right? Okay. And here I called the add change function to add this change for this document, right? Okay. So the next change I want to add for this document is the change to the parameter type, right? Okay. Okay. So here I created the change to the parameter itself, and notice here I didn't add the annotation like I did in the previous video because we don't want to track this parameter between different versions of the document, right? Okay. So we used this code before to update the document and we don't need it now. Okay. We also don't need this code that searches for the parameter in the updated solution, right? Okay. So here we are searching for the parameter in the solution, and we can now use the solution without any modification and a parameter symbol based on the unmodified version of the parameter syntax node, right? So now we are finding parameters of caller methods that are used as values for our parameter using the unmodified solution and the original parameter symbol, right? Okay. So here we are looping through caller parameters, and here instead of changing the solution, I'm going to add a new change. Okay, let me add the change now. Okay, so far we didn't do any change, right? we simply defined how the changes should be made, right? Now I'm going to prepare the list of changes and then use the method we created to update the solution. Okay, so let me run the test now. Okay, great. The test passes. So let me run all tests now to make sure I didn't break anything. Okay, great. All tests pass. Okay. So to summarize, here, when we find source parameters, because before we made changes to the document, trying to get an operation for the invocation failed because the first change we did created an error and prevented the semantic model from constructing a valid operation, right? Now, because we are using the original solution to find the invocations and to get the operations here, we are getting back a valid invocation operation, right? And here, using this operations API, we were able to find the argument that corresponds to our parameter, right? Okay. Okay, thank you for watching.